In part A, we're trying to complete the sequence and explaining how we do that. So I noticed that these numbers are decreasing, and if I subtract 25 and 16, I can see that they are 9 apart. So I know that I subtracted 9. And sure enough, if we do 16 minus 9, that's going to give me 7. And 7 minus 9 is going to give me -2, and so on. So we're subtracting 9. This one I can see as letters, so I want to think about the alphabet. Starting with C, I know that D comes next, and then E, and then F, G, H, I, J, and the next letter would be a capital K. So I think we need to say that we start with C. Starting with C, write every other letter of the alphabet. Write every other letter of the alphabet. Okay. And then it appears that these numbers are getting larger. If I add 7 to -6, that will give me 1. If I add 7 to 1, I get 8. 8 plus 7 gives me 15. It works every time, so we're adding 7. All right, determine if the conditional statement is true or false. If it's false, we need to be sure that we're ready to give a counterexample. So if it is an even number, then it is divisible by 2. A -8's an even number, but I can divide that by 2. 0's an even number, but I can divide that by 2. 12's an even number, it's divisible by 2. I get nice, neat answers. I can't think of a counterexample, so I'm going to need to say that's true. If it's a bird, then it's going to fly. That's false because I'm able to think of a bird. An ostrich is a bird, but it can't fly. So there's a counterexample. Remember, we want the hypothesis to be true, but the conclusion does not follow as a result of that. All right, if angles have the same, two angles with the same measure, that's my hypothesis, then they are congruent, that's gonna be my conclusion. All right, so in this first problem, I can see that the they are congruent part came to the front and the they have the same measure part went to the back. All we did was swap them out, and that happens with the converse where we swap the hypothesis and conclusion. In this one, they are congruent, two angles are not congruent. So we brought that original hypothesis to the front and changed its value. Instead of the angles have the same measure, they do not have the same measure. So that's going to be the contrapositive. And then if two angles do not have the same measure, so up here the angles have the same measure, now they don't. It stayed in the same place, but I changed its value. They are congruent, they are not congruent, and that's the inverse. Okay, when we name the properties, we just want to know what changed. So it was x equals 7, now it's 3x equals 21. I could get that by multiplying 3 by x and 7 by 3. So we used the multiplication property of equality. We did it to both sides. So this one has 3 statements, and I'd like you to notice that in the original statement, we had y equals 5x minus 2, and we know that y is equal to 13. And then the only thing that changed in the green statement up above is that now the y has been replaced with the 13. Everything else remained the same. Because I replaced y with its equivalent value, that is substitution. In this one, the left side and the right side traded places. Nothing else changed. That's the symmetric property when we swap out the left and the right. And then here, it was 2x minus 3, now it's just 2x. The 3 disappeared, and if you add 3 to both sides, the 7 would become a 10. So that's the addition property of equality. We did it to both sides. All right, on our proof, here is what we're given, and that is the very first thing. That was free. What changed going from here to here? I took that 3x and 11x and I put them together. The 9x stayed the same. I didn't add something to both sides. I just grouped up my like terms, or I collected like terms. By the way, given was D, and collect like terms is I, if you wanted to use the letters there. All right, what's changing going from here to here? The 14x is disappearing. That happens by subtracting 14x from both sides. So we did the subtraction property of equality, which is F. And then the -5 is gone that was with the x. So we divided that away. And just to double check, if you divide -4 by -5, you do get +8/10. So we divided both sides. That's the division property of equality, which is H. And then finally, we just took this and we flipped it. We traded out the left and the right. We saw that a minute ago. That's the symmetric property when we do that, and that's answer choice B. Okay, and all the rest of these are going to be our angle relationships. So you can see that A and B are inside the lines. This is the transversal. The lines are parallel. These are alternate interior angles. And because the lines are parallel, I know they're congruent to each other. And this one, A and B, lie along this transversal, and these are the two parallel lines. A and B, when you look at the 4 angles, they're in the same position. Those are corresponding angles. And because they're formed by parallel lines, the lines were parallel, those are also going to be congruent to each other. We have parallel lines again, and here's my transversal. Remember, everything in between the lines is an interior, so these angles are on the outside on opposite sides of the transversal. Those are alternate exterior angles, and when formed by parallel lines, those are always congruent to each other. In number 4, there's the transversal, and we're looking at y and x, and y and x are both inside the 2 lines that were crossed by the transversal on the same side. Those are consecutive, meaning one after the other, interior, consecutive interior angles. If the lines were marked parallel, I would know they were supplementary, but I don't know that. All right, and now we're going to just find the measure of the angles. So once again, B and 51 are along this transversal. The lines are parallel. These are alternate interior angles, and those are always equal to one another. B is going to be 51. Here's the transversal, and these are the parallel lines. B's on the inside and 42's on the outside. That's your clue that these are sitting in the same exact position as you travel down the transversal. Those are corresponding angles, and corresponding angles are always equal. Find the measure that makes the lines parallel. Well, these are both inside the lines, they're interior angles, and they're on the same side of the transversal. Those are supplementary if the lines are parallel. So we want to do 180 minus 51, and that's going to leave us with 129 degrees. If indeed these lines are parallel, both of the angles that we have here are on the outside, and alternate exterior angles should be equal to each other if the lines that form them are parallel. Okay, and then when we come down to the bottom, we hit some that involve some algebra. So I can see that the lines are parallel. Here's my transversal. One of them's on the inside, the 8x minus 6, and the other's on the outside. That's my clue that they're sitting in the same spot. They're corresponding. Corresponding angles are equal. So we'll set 8x minus 6 equal to 7x plus 5. Subtract 7x from both sides, and we have x minus 6 equals 5. Add 6, and x equals 11. On number 2, they're parallel, and these angles are both interior angles on the same side of the transversal. These are our supplementary angles. They're going to add to 180. So I'm going to add these two things together. 15x plus 5 plus 100 is 105. That has to equal 180 because they're supplementary. Subtract 105 from both sides, and you get that 15x equals 75. Divide both sides by 15, and x is 5. So I want these lines to be parallel, but these angles are interior angles, and they're on opposite sides of the transversal. That makes their alternate interiors. I need those to be equal if the lines are going to be parallel. So we'll set those equal to one another. Let's get our x's together first. So negative 4 plus 2x equals 12. Go ahead and add 4 to both sides, and you get that 2x equals 16. Divide both sides by 2, and x equals 8. And then finally, so this is really just a matter of kind of interpreting all of this as well as the picture. We don't have parallel lines here for sure, but if the measure of 1 is 55 degrees and 1 and 3 are congruent, that means that this is also 55 degrees. We want to find the measure of angle 2. Well, they don't make a linear pair, but these 3 angles will equal that complete 180 degree rotation. So 55 plus 55 is 110. If we subtract that from 180, that's going to give us the measure of angle 2. The measure of angle 2 is equal to 70 degrees.